So what this function looks like, if you graph this function, where z is the height, it will be a surface in three dimensions that looks like a smooth hill. And the top of this hill will be a height of 10,000. And that will correspond to an x value of 100, a y value of 100. If you look in the book, the picture that's most representative of this will be on in chapter 11 on page 294. At the top of page 294, that point A would correspond to the maximum, the top of the hill. Let me, for those of you who don't have the book, let me just try to, I'm not particularly adept at this, but let me just try to represent what this surface would look like in 3 dimensions. It's a little bit tricky trying to do it in 2 dimensions, but this is what it would look like. Let z be the height of the surface. And following the book, let this axis right here represent the value of x. So x is measured along this axis right here. And let this axis right here be the value of y. If you were to graph this surface, let's look at the equation before we do any more graphing. The equation was this. So it should, if x and y are both 0, what is the value of z? 0. So this origin should be 1 point. So it's going to look something like this. Okay. Where this would be your point A, this would be your maximum value, 10,000. And this is your value of y. And your value of x, so this is the tricky part. Okay, this has to go down here quite a bit. Okay, so, see, I need to make this a little more curved. See, I told you it was tricky. This has to go down, and this point right here would correspond to your y value. Or your x value, I'm sorry. So this point here is the x and y values are each 100. And then you go up, and the height of this is 10,000. So it's kind of a rough picture of what it looks like. Okay. All right. All right. Any questions over that?